Okay. So.
Hello. This is the last lecture talk or lightning talk. It will be a set of 2 lectures from the toolchain team. So the first speaker is Martin Čermák, and let's hear his lecture talk about testing system tab.
So thanks. So I'm going to summarize briefly some basic points with regard to testing system tab. System tab is a tracing and probing framework originally mainly used for tracing kernel, but currently it can be used also for tracing and probing user space. And I'm currently the tester of this thing in Red Hat. So what's the main goal? The main goal is to put fresh bits everywhere where possible. So we are rebasing where possible. And so I'm basically trying to, or focusing to test fresh upstream bits on fresh Linux kernel. And that is basically what I'm going to speak today. For testing system tab, the upstream test suite can be used as well as various QE test cases. Thing is that some test cases don't fit into the upstream test suite, for example, those that rely on rebooting. System tab currently supports features like, for example, early boot probing, which require a reboot, and this can't be very well tested within the upstream test suite. So these are cases which are tested somewhat aside. But we are trying to keep the most test cases inside the upstream test suite. The upstream test suite, as such, contains some 400 test cases. Is based on Deja GNU, which is a testing framework based on TCL. The time consumption of the test suite is relatively high. It depends on the architecture following way. The test suite tests follow several runtimes. Currently, kernel and Dynst runtimes are supported. And the test suite tries to go through both runtimes if possible, but Dynst isn't available, for example, on S390, so that means that on this architecture, the suite runs significantly faster. But in usual case, the time consumption may be up to 1 day to run whole test suite. We are basically using Beaker project.org thing, which we use for provisioning machines and running our tests. To run the upstream test suite within Beaker, we need some simple shell wrapper, but nothing really special. So, the whole thing is very easy. We need to get results and then somehow present them and process them. So getting results seems to be as easy as just instructing Beaker to provision a box and run the upstream test suite in it, and then grab results and process them. There are a few issues which need to be resolved. First of all, the reliability of Beaker is not 100%, so this needs to be handled somehow. We have a tool called Beaker JobWatch for that, which we would like to include in Beaker as such, but we didn't happen to manage that so far. But this is relatively fine. Then what's more interesting is that the test suite as such can cause kernel crashes and stalls, which is kind of thing which needs some attention. So how to handle these in Beaker? Beaker doesn't support, Beaker support reboots, which is fine. Thing is that when a kernel crash happens, not all the stuff is properly synced to hard disk drive, so the machinery need not work in an ideal manner. So when the kernel crash happens, we usually want the machine to reboot. This is not always the default behaviors. So in order to set this up, we might need some tweaks in kernel setup, like which will force this behavior. There are some settings like which enforces this, and also there are settings that can be used for forcing the kernel to reboot also on oops, which is not exactly a crash. So after we have this, then we are able to run the test suite in a way that after a kernel crash it reboots. After that, we need to somehow detect in the test suite that the kernel crash happened and be able to somehow continue from the point where it stopped. This is not so straightforward as well, because Beaker has a few variables that can be used to handle reboots, but when a kernel crash happens, then not all these variables need necessarily be set up to the right values. Because of, for example, disk syncing, not all the data are written at the moment of the kernel crash. So what we are using here is that when the test suite runs, it produces relatively high amount of data, so that the cache, disk cache is not that much of a problem. And when we get back after a reboot, we can just check if there are already some data, and if there are some data, then we can expect that reboot happened, and we can just continue. So these are kernel crashes and stalls. This still is not completely enough. Sometimes it happens that the thing still hangs. So to handle this, we can use some external machine which controls the testing box, and if it, for example, stops responding to ping, then we can reboot it and continue testing. Also, other types of stalls might be based on that if there's some update to the kernel, then there might be some renamed syscalls and similar things which will cause some test cases to just hang. For this purpose, timeout feature was implemented upstream in the test suite, so that we are now able to handle this as well. Also, some problems are caused by that the test suite emits some signals that might also break the Beaker thing. For this reason, we need to catch these signals, and after that we are fine, and we can go ahead to processing results. So. And then also we are using blacklists to blacklist problematic test cases, but after implementing all the mentioned stuff, we usually don't need them, just that if we want to get rid of some tests which we know that are problematic for particular time, we can use the blacklist, but I'm not inclined to use this in general because it needs maintenance and it's not really convenient. So this way we are able to get results in Beaker, which is cool, and we can go ahead to results. Results currently look like this. I said that the test suite has about 400 test cases, so as you can see in the table here, each table represents one test case. Each line of the table represents one architecture, and each section of the table like this represents one upstream commit. So we can see a few upstream commits here for a few architectures. This is for RHEL 7. Similar testing is being done for other RHEL variants as well. So having a look at this table, we can see how the test suite currently looks like. We can have a look at a few bugs which were reported just recently and have a look at how they were caught using this test suite reporter. So in this bug, it turned out that system.tab doesn't compile because of some commit on all the RHELs. This really won't be visible on this table because this is just with regard to RHEL 7, but in the respective table it will be clear that the thing stopped compiling. In this bug, we can have a look at the test case. So here we can see that something really broke. Let me note that sometimes it might happen that some test case might give some unreliable, or let's say unreliable or not very reliable results, or better said, results that are affected by other things happening in the system. Maybe there might be some higher load, or the system might not have enough memory or stuff like that. And this, you can see such a result in this table as a standalone red point. So this table actually also serves as an overview which gives some kind of quick statistics of what is happening here. So in this case, it's clear that something happened here, and one can start investigating the problem. And the third bug, let's see. And the third bug is about a test case that is quite new. There were no results before that, and once the test case appeared, it was failing. So this is how it looks like in results. So this is a kind of global view of, let's say, continuous integration effort of system.tab. Tests are not being run each day. I was trying to do that from the beginning, but given the time which is needed for running the test suite, this doesn't look like a very realistic way because it generates really high load in Beaker. So currently, these tests are being run during weekends where relatively high amount of machines are available and tests can safely run. So that's basically it. Do you have some questions? So if there are no questions, then that's it, and thanks.
Okay, thanks. And now the second speaker will be Miloš Prchlík.
Much better. Okay, thanks. So, hi, my name is Miloš. I work at Red Hat in a toolchain QE team, and this was announced as a lightning talk about Eclipse testing, but later, like in the second half, I will get more to a rant of a console-based guy about graphical user interfaces testing and this kind of stuff, and I will mention a short list of lessons that I personally learned during the Eclipse testing and other projects we worked on. So the first thing in Red Hat I encountered was Eclipse. It's a quite large integrated development environment, mainly for Java, but by the means of some plugins, it's quite extensible, and in Red Hat Developer Toolset, it's part of a Red Hat Developer Toolset because of a set of plugins that allow developers to develop with C and C++ using Eclipse and using the standard toolchain, GCC, GDB, Valgrind, and other tools you can meet during development in Linux. So how to test it? That was like the first question, because it's mostly a graphical application and it's completely different world. So there was upstream test suite. Actually, there was more than one of them, and the main one that was the part of the project of the main cornerstone of the Eclipse. It's quite large, quite extensive, and very time-consuming. It takes on a regular Beaker machine, it took like, let's say, 8 hours to finish. But it produces a huge pile of results, but there's also a very, very small number of failures. So it's like 1 or 2 failed test cases in each test run. And so it's easy to like deal with the fails, but it's hard to find them between the different test runs, and continuous rebasing for each dev2set testing cycle. Also, there were no tests for the graphical user interface itself, because that was like the most important part, because the tools that were supposed to be that developers were allowed to use in the Eclipse were used by setting some graphical controls, like buttons and radio boxes, checkboxes, input boxes. You select several options. You typed other options. You clicked on some buttons, and Eclipse plugin translated this to a command line, which was run on the background, like a normal standard Valgrind process, for example. So one of the main goals was to test if Eclipse, if this part of Eclipse, of the plugins, if the graphical user interface actually works like was intended. So after a few dead ends, we managed to somehow start with testing, and I would like to share with you a few lessons that I personally learned during the development of those tests. The first and most important thing is there are dozens of frameworks already existing, and actually some of them are quite good, and it's not necessary to reinvent the wheel. So the framework is the testing framework for this kind of testing actually exists. I decided to use a project called Red Deer, which is developed in Brno by JBoss guys. They use it to test their own applications, and they write their tests. So it's quite actively maintained. The other thing is like the most painful thing about the graphical user interface testing was that everything was quite fragile. There were timing issues, there were controls that were actually visible on the screen, that were clickable, but the framework was unable to find them in the object model. So, and this was a one-time thing, and in 10 other runs, you never encounter this kind of issue. So it's very fragile, and this caused a lot of trouble, and therefore I wrote a lot of scripts to help with results, with files that were produced by tests, and that allowed me to find out the real fails, real issues that are to be fixed or investigated, and that allowed me to replan and rerun the issues that were known, that were caused by some strange behavior or environmental issues that were not actually Eclipse, or that were not actually bugs in Eclipse or in plugins we tested. The third thing is that we are kind of used to that we can log pretty everything when we work with command line. All our tools have some options for logging files, verbosity settings. There's nothing similar when you try to test graphical user interface. You can log actions, you can log how you send events, but when you want to investigate what actually happened, the important thing. I'm not saying that is the most important, but important thing is the view of the screen of the application you are testing, if it fits to the expectations of your test or not, or what was happening during the test run. So there are a few ways how to log this state of application, from screenshots to some video capturing, and this is also one of the things that are not as easy as with some command line tools. The next thing is that those plugins for C and C++ development are constantly developed, maintained, bugs are being fixed, dialogues are changing, controls are being renamed or moved to different pages, and the things that were on one place in DevToolset 2.0 are moved to a different dialog in DevToolset 3.0. So this is also a thing that, because it's based it's based on the development of user experience. So this changes a lot, and when writing tests for graphical user interface, this is also a thing you have to take into account. The next thing, the framework we used works in a way that it runs like a part of the Eclipse process. It can manipulate its objects, read values, send events to objects inside Eclipse. So it's the whole thing, like click on this button, read this label, check if this dialog is visible. This whole stuff is done by sending events, by capturing events, listening to events, and this kind of stuff. But it also means that this such a test has no idea how to interact with the world outside of the Eclipse process. In case you want to change something or modify something, some external settings, you have to start another process. You have to start, for example, your helper script, and wait for it to finish, check if it's failed or not. And this was actually painful in case of, let's say, OProfile, which didn't work in the first release under some user account. It was necessary to type a root password to allow all OProfile utilities to set up kernel and other things. So it was necessary to wait for policy daemon dialog to pop up so user can type root password. But the test itself has no idea what's going on in the rest of the system. So manipulation with this is not always easy. And and the last thing I want to mention is that because this testing is based on a framework that works from inside, and Eclipse has a large set of, let's say, standardized controls like buttons, labels, select box. There also, it's not hard to create your own controls, which guys from C development toolkit did a lot. So there are things like Valgrind's tool Massive can log data about the heap usage, and Eclipse plugin was created so that can create a chart from these recorded data. So the actual chart is a custom-made control that was written by developers of that plugin, and our framework, our test, has no easy way how to interact with such control. It has no standardized methods like other controls. It's not on the first sight. It's not visible how to access the chart, how to check it, how to test if it contains the same data, how to save it, or how to control it. So, yeah, I think this is the last point I wanted to mention. It's completely different world, and I've met also some other like graphical user interfaces that we had to test. I worked with Doctail. It's written in Python, and it's designed to allow testing of GTK applications. Few points of that are also true for Doctail, but yeah, it depends on the case. So don't expect, in case you are supposed to test some graphical user interface, it's not that easy as running some command on command line and grabbing for result in log file. So if there are no questions, yeah. We test what?
Can you test the console output for the various links we'll do?
Console output, if we can test the output of the underlying login process? Yeah, definitely. All those plugins that handle these tools are written in that way that standard output of that running tool is usually redirected into some, it's called console. Console in Eclipse world, it's a tab with a text area where the output is stored. And actually, I did test it, the output of those tools for real. It was saved, it was grabbed for results, for expected values. So yes, also with running the tool without Eclipse with the same data, if it matches the output of the tool that was run under Eclipse. So, any other questions? Okay, thanks.
So this will probably be it. There will be some refreshments in the at 7 p.m. So you can grab some. Yeah. Thanks.